Hello again. So, we have another problem. Lots of parallel lines, which means lots of congruent angles. And it wants us to, let's read the problem. Given that DE is parallel to BC and AY is parallel to XC, prove that EY over EX is equivalent to AD over DB. Now, if you had no idea what you were supposed to do in this problem, there's a couple of hints at what you should be thinking. The most obvious one is that it wants you to prove some sort of ratio or a proportion, that these two ratios are in fact the same. Now, whenever you have ratios and proportions, you should probably be thinking of similarity. And the fact that we have these parallel lines, the most vital reason for them in geometry is equivalent angles. You have to know that parallel lines will give you equivalent angles, and you must make sure you know exactly which ones it will give you. For example, we have the twice marked parallel lines AY and XC. They have two transversals, AC and XY. I'm just going to focus on the AC one. So AY parallel with XC, transversal with XY. Well, what does that do? Well, that means this angle here and this angle here, they have to be the same. So I'm going to say that angle AYE is congruent to YXC. And please, before I even say the answer, maybe even pause the video and think about what is the reasoning that these two angles are equal. And it is parallel lines, but make sure you understand exactly why. It's the fact that they are alternate interior, which I will abbreviate as alt-int. Alternate interior. Just as a refresher, that means look at the parallel lines. Interior, meaning inside the lines, all that stuff on the inside. Alternating sides of your transversal YX. Okay. With that being said, now let's find some other pairs. Now, if we were to continue on with our theme of parallel lines, we could realize that, well, A or YAE, this angle right here, is on the parallel line AY and is on the common transversal AC with the parallel line XC. So that means that these two angles are equal. So YAE is congruent to XCE for the same exact reason. They are alternate interior. We could have also noted that AEY and XEC are the same because they're vertical angles. But it doesn't matter at this point because we have sufficient information to show that the triangles AYE and CXE are similar because of angle-angle similarity. Now, once we have similarity, we should try to come up with some proportions. So, one proportion being, well, if I notice the AY is between the two marked angles, the one with one mark and the one with two. So maybe I could start with AY. And that must clearly match up with the one XC, because that again has the single marked angle here and the double one. Well, what is that equivalent to? Well, what's another side we have? We have YE. So YE goes with the single marked angle to the unmarked. Well, that would be XE on the other triangle, the single marked to the unmarked. And then finally, we have AE over CE. So that is the following proportions that we can set up based on the similarity that we currently have. Now, is there anything in here that we really like? Well, I'm trying to find EY and EX. I have YE and XE, and that's the same thing. You can just reverse the order. In fact, I might as well just do that now to make it a little bit easier. They're the same thing, and hopefully you understand why, but we'll just write it in the way the answer would like it. EY over EX. So that's good. Now, anything else in there we like? Well, AD doesn't seem to appear, and DB doesn't seem to appear. So let's try to find another pair of triangles that potentially are the same. And I'm just going to clear up all the markings, and so I can clearly see what I'm looking at. Well, we have two other parallel lines, DE and BC. Well, parallel lines mean angles are the same, so let's try to come up with something like the fact that this angle here, ADE, must definitely match up with DBC because they are on the parallel lines DE and BC sharing a common transversal AB in the same relative positions. So that is good. Now, what else could I possibly show? Well, the same logic could show me, well, let me write that out a little bit. ADE is congruent, the angle is congruent with ABC because they're corresponding on parallel lines. So those two angles should lead me to start thinking, ADE and ABC might be the two triangles that are similar. Is there any other angles that I could possibly show? And I am just going to go the easy route and say they both share angle A. So I'm just going to write angle A is congruent to angle A. Now I have two pairs of congruent angles. Hence, now I know I have similarity. Triangle ADE is similar to triangle ABC. So now we can write all the ratios associated with those triangles. For instance, let's say, well, we want AD in our answer, so let's start with AD. What side does AD seem to match up with? Well, that would be the side AB. And that is equivalent to, well, we have AE that seems to match up with AC. And then we also have DE matching up with BC, the two parallel lines. So, anything like there? Well, AD is good. AD's fine. But it's over this AB. Now, the AB might be causing me a little bit of problems. However, I do notice that the thing the two things I want, EY over EX and AD over DB. Well, EY over EX is equal to AE over CE. That's something, but not quite what I'm looking for. So there doesn't seem to be a real clear equality that I can go with. So let's just try some things out. So let's look specifically at our ratio AD over AB. Well, what is that? Well, what is AB, for instance? AB can be split apart in the following way. AD is going to stay the same, but AB is the same thing as AD plus DB. And now I'm starting to get somewhere. I have AD on my numerator, which I like. That lines up with what I'm trying to prove. And I have a DB in the denominator, just a little something extra. But I noticed that it's equal to AE over AC. The other, so I was focusing mostly on this side here. So I'm going to do this part in red so it stands out. Let's focus maybe on this side, because I'll try the same trick. And I'll even set them equal to each other, this AE and AC, because we have shown they're proportionate. So AE, well, I'll do it over here. AE over AC. Well, what is AC? Well, that can be split up as AE over AE plus EC. And now I'm definitely getting somewhere. Because if I notice in my first set of ratios, I have an AE over CE or EC. So this seems to be matching up with this. And again, because I know AE over AC is the same thing, or is equivalent to, I should say, the AD over AB, I can then set them equal to each other over here in that split up form. So we are going to have AE and then AE plus EC. Now, I'm going to erase some of this fluff, all this arrows and stuff. It's a little distracting, and I'm even going to erase that initial simplification, because right now I want to focus just on this. Now, one thing that math teachers, I mean, you can work this out logically by doing cross multiplication, division, but the trick I'm going to use is fairly simple. It's the fact that, like, if you have 2 over 1 equals, I don't know, 4 over 2, whatever, then it is also true that 1 over 2 is equal to 2 over 4. If I flip the fractions, there is still an equivalence, and you still get an equivalent result. So that is something I can absolutely do here. And the reason I'm doing that is because then I could split up the numerators. So what I mean by all that fancy terminology is the following. I'm going to rewrite it in the following way. AD plus DB over AD is equal to AE plus EC over AE. And if you have a hard time understanding how I did that, I would encourage you to try it out yourself. Try multiplying. You could try cross multiplying. Just don't distribute. Just leave it like separated and just divide stuff over. If you're absolutely lost, you can come to tutoring. I can show you a more detailed explanation. But for right now, it's not so crucial to the problem that I'm going to focus on it for a while. The reason I'm doing it is because you can't split up denominators, but you can definitely split up numerators. And I am going to do that like so. AD over AD plus DB over AD is equal to, and I'm going to separate it the same way, AE over AE plus EC over AE. Now, why would I possibly do that? And this is just basic fraction knowledge. If they have a common denominator and you're adding them, you can split them up like that. This helps me see, well, AD over AD. What does that become? Well, any value over itself is just 1. Besides 0 over 0. But you can't have a side length of 0. So that is going to simplify to 1. And then we have DB over AD equals, same thing, AE over AE is just 1. Then we have plus EC over AE. Now, if I were to subtract 1 on both sides, that would certainly cancel out the 1s. And I am just going to do some really silly stuff right here. I'll make sure to cut this off so that it's not a part, we see it's not a part of the problem. So where do we get? We get that DB over AD is the same thing as EC over AE. Now, what is all that about? Well, I'm trying to find this equivalence. It seems so long ago, but I'm trying to show that this is true. Well, I have DB over AD. So let me do the same trick and let's flip back to how we had it before, where AD was on the top and DB was on the bottom. Equals, we have AE over CE or EC. Now, this is pretty much it, because what do we get now? Well, in the beginning, we have shown that EY over EX is equal to AE over CE. And that C is looking a little rough there. Let me clean it up. That was shown in the very beginning. And now what we have shown is that AD over DB is also equal to AE over CE, which means that by simple substitution, we can finally get the desired result we were looking for, which is that EY over EX is equivalent to AD over DB, the desired result that we would like. Now, that problem was a lot, and there's a lot of tricky algebra to it, Just make sure you understand how, I mean, the important part is the similarity. Make sure you understand how I got that. Make sure you know how to write the ratios, especially in these parts here. The algebra, that just comes with practice. But the new geometry stuff, make sure we have a good handle on that when we are ready for our future exams.